The VA4 and VA5 ADAS analyzers are very powerful instruments for vibration diagnostics. In this video, we will show how to use them for turbine vibration measurements. Contactless proximity probes are usually mounted on the turbines. These sensors use eddy current principle for measurement. Buffered outputs from these sensors are always available, and these outputs we use for measurement. Eddy current sensor function is simple. The output voltage is proportional to the distance between sensor and shaft. The output voltage is negative. It can be confusing for some people. If the gap is higher, then higher negative voltage is on the sensor output. But I can say the lower voltage is on the output. The words higher negative is equal to the word lower. Example of some gap is on this picture. The output voltage is minus 8 volts. On this picture is higher gap, and we can see the higher negative or lower voltage minus 11 volts. Now the shaft begins to rotate. The distance between shaft and sensor is changing in time. Output voltage is of course changing too. Looking on the signal, we can see the highest and lowest voltage values. Now we switch the view to the gap values. But it's confusing. Usual understanding for measurement of anything is that the higher output voltage from the sensor means higher physical value. For example, higher voltage means higher temperature, higher pressure, and so on. But we can simply fix it on our analyzers. We only need to set correct values of sensitivity and offset. We need to set negative values for them. Sensitivity of the sensor which we use is 8 mV per micron, and the zero position of sensor is 2 mm from the shaft. Then we need to set these values. The sensitivity and offset for DC channel. The 16,000 mV is the voltage which corresponds to 2 mm gap. And just the sensitivity for AC channel. Don't forget to switch ICP off. You could destroy the buffered output with ICP on. This is the math formula which is used for recalculation. We need two sensors for measurement on one plane. We use A and B labels. There is usually 90 degrees angle between sensors. Correct sensor angle setting is necessary for correct results. Here are several examples. Now I want to explain A and B marking and direction of rotation. Direction of rotation is important for some analysis. Please note the 90 degrees angle sector and note the rotation direction. If I mark some point on the shaft, red spot, then this point must come firstly to the sensor A and then to the sensor B. The angle can have different value than 90 degrees. We always use the angle sector which is lower than 180 degrees. This is complete typical setting of AC input. This is complete typical setting of DC input. The phase information uses the key phaser spot on the shaft. It is a tooth which is mounted on the shaft or the hole which is drilled to the shaft. Of course, it is done on different plane than the plane with A and B sensors. Another eddy current sensor is used for this measurement. The signal is flat with regular pulses. What is the phase value? It is the angle delay of vibration high spot, means highest gap, after the key phaser position. Yes, I agree with you. Such sentence is not understandable, but next pictures will explain it better. Here you can see the key phaser position is exactly the same as vibration high spot. The phase is 0 degrees. When the high spot is delayed of half of time period of speed, then the phase is 180 degrees or minus 180 degrees. It is the same. When the high spot is delayed of a quarter of time period of speed, then the phase is 90 degrees or minus 270 degrees. It is the same. I hope that now you fully understand the phase logic.